Hello guys, and welcome to the next video in which I will show you how to use Retrofit 2 with Kotlin. If you stay to the end of this video, I am sure you will be able to handle 99% of cases you will encounter in your projects. Just before we start, a quick reminder that you can find many more videos related to Kotlin and backend on my channel, so I encourage you to check out them after this one. Okay, so before we start the practice part, let's figure out what exactly Retrofit is. In simple words, it is a type-safe HTTP client for Android and Java. So if you are looking for a library which will help you to integrate external API in your mobile application or a backend service written in Java or Kotlin, then Retrofit is definitely worth a try. To be even more specific, it is built on top of OkHttp, another popular networking library by Square, and provides a higher level abstraction to define API endpoints and handle responses in a type-safe manner. With all of that said, let's start the practice part. And the first thing we need to do is to create a brand new project, and I will be using Gradle. So let's specify sign name, Retrofit. It will be put in the downloads, I don't care about this. The build system, I will specify Gradle. JDK will be 21. You need to keep in mind that Retrofit requires at minimum Java 8 or Android API 21, so it won't be compatible with the legacy code base. For the Gradle DSL, I will use Kotlin, add sample code, we can delete that later. With all of that done, let's hit create button. Okay, so the project is creating. We can see right here that the Gradle is building. It may take a while before it syncs. When it finishes, let me clean up the main function a bit so that we can focus later on Retrofit. Let me delete this and this line as well. Nextly, we'll need to add the Retrofit dependency. So as the next step, let's open up our favorite web browser and navigate to Maven repository, mavenrepository.com, and right here let's search for Retrofit. Enter. Let's go right here and let's use the latest stable version. Wonderful. Let me copy this line, Ctrl+C, and let's get back to IntelliJ and simply navigate to build.gradle.kts. Let's paste the value, delete this one, and let's sync the project. Again, this may take a while. IntelliJ will be fetching the necessary dependency. Additionally, we'll need something to serialize and deserialize objects, because by default, Retrofit allows us to work only with OkHttps, request bodies, and response bodies objects. And although sometimes it may be sufficient, in most cases we would like to make use of some serialization library when dealing with payloads. And thankfully, we can achieve that pretty easily by importing desired converter to our project. On this list we can see that Retrofit supports JSON, Jackson, Moshi, Protobuf, and for the purpose of this tutorial, I will be using the Jackson library, so we need to add the following to the Gradle. Let's get back to Maven repository and search for Jackson Retrofit. Let me hit search. And right here, we can see the converter Jackson. Let's specify the exact same version as we did for Retrofit. Let's get back to IntelliJ, paste it underneath, go to Gradle, sync the project. Wonderful. As the next step, let's see how we can configure Retrofit to work with Kotlin. Firstly, let's add an example user DTO to our project. Let me click right mouse button right here, new, Kotlin class file. Let's select the data class and let's call it user. I would like this class to have three fields: ID, name, and age. Val ID of long type, val name will be a string value, and val age will be integer value. Additionally, I would like to mark all of these with JSON property annotation. Add JSON property, and let's specify the name, ID. Let's copy this value, Right here I would like to add name and similarly age. So as you can see, this simple class expects simply a JSON file with ID, name and age, all non-null values. Following, let's create the retrofit client object. Let me click again, right mouse button, new Kotlin class /file, and let's add the object retrofit client. The first thing I would like to do here will be to specify the base URL for external API. So let me hit enter, private const val base URL. This may be constant because this is a string value, and let's specify the URL http / localhost. The port will be 8090 /v1 /. The important thing to mark here is that the base URL in retrofit must end with / because otherwise the request will fail with illegal argument exception. Next, let's add the function called getClient that will return the retrofit instance. Fun, getClient. It will not take anything, but as a response type, I would like to return retrofit. Wonderful. Equals. And now let's build the retrofit instance. Retrofit.builder. Let's instantiate that. The first thing I would like to set here will be the base URL, and we'll use the constant we defined already, base URL. Let's specify the value from base URL. Nextly, I would like to add the converter factory. Simply for object serialization and deserialization, add converter factory. And this one should be the Jackson converter factory. Jackson converter factory dot create. We'll use the static method to instantiate that. Lastly, we need to build the instance of retrofit. Ctrl+Alt+L to format the code. Wonderful. Lastly, just wanted to mention that by default, the OkHttp client will be used underneath as a factory for calls. With that done, let's see how to handle retrofit responses in our Kotlin codebase. So let's simply start by adding the user API interface. Again, right mouse button on the Kotlin package, Kotlin class /file, select the interface, and let's call it user API. What I would like to add here will be the function to fetch users from the external API. Let's create a new function, fun, get users, and this function will return the instance of a call from retrofit and a list of users. Lastly, I need to annotate that with get annotation, get, and specify the path. Alt+Enter, let's import the get. So again, we can see that our function will be used to perform get requests to localhost 8090 port /v1/users. Later we'll take a closer look at all supported HTTP methods, but for now let's discuss the call interface. A call is basically an invocation of a retrofit method that sends a request to a web server and returns a response. It can be used synchronously with the execute or asynchronously with enqueue methods. Additionally, each call can be cancelled at any time with cancel. In this video, we'll focus on synchronous calls. However, if you would like to learn how to work with retrofit and Kotlin coroutines, please let me know in the comment section. I will be more than happy to make a continuation of this topic. But right now, with that done, let's add a user interface and make use of our configuration. So again, right mouse button, new, Kotlin class /file, and I would like to add a new class, user service. Wonderful. The first thing, I would like to get a new client, private val retrofit equals retrofit client. This is our object that we used, and let's invoke the getClient method. Nextly, let's introduce the user API. So we'll introduce private val user API equals. Now let's use the retrofit instance dot create, and we'll instantiate a new service, user service, reference to the class. Wonderful. At this point, we have basically everything we need to query the endpoint, except the actual API. For the purpose of this tutorial, I would like to show the mockun. Mockun is a tool that you can use to mock external API. You can do that in various ways. I highly encourage you to check out this tool to do that. So let's hit new environment. I'll call it Retrofit. This will be simply a JSON configuration persisted on your local machine. And let's navigate to settings. The port I would like to specify here was 8090. And let's specify a new root. Get /v1/users. The response 200, okay. Body. Right here, I can simply specify what we would like to return, and as you remember, we would like to return a list of users with ID, name, and age values. ID will be some long value 1, 2, 3. Name will be some name, and age. Let's go with 25. Right here we can format the body and start our server. So whenever we'll make the call to localhost 8090/v1/users, this body will be returned with 200 OK requests, HTTP status code. So let's get back to IntelliJ and let's see what information about the response can we obtain with Retrofit. Let me introduce a new function, fun, successful users response, and I would like to query the API. So val user response users, let's make it plural, equals user API. Okay, I made a mistake right here. Instead of referencing the class, we must reference our interface, user API. So I was technically referencing the same class. Now we can go with get users. And as I mentioned previously, execute method. Basically, this method returns the response object, which lets us obtain info about the response. We can see right here, generic response instance. So let's introduce a few things. I would like to figure out whether the response is successful. Well, successful equals user response is successful. Nextly, let's figure out what was the HTTP status code. Val HTTP status code equals users response dot code. And for example, HTTP status message, if you would like to figure out what was the message, HTTP status message, users response dot message. Let's print out those values, print successful, Ctrl+D, Ctrl+D. Let me copy those values. Excellent. The last thing we need to do will be to simply invoke our functions. So let's go to main. Let's introduce our service, val user service equals user service, and let's call our API, successful users response. Let's hit right here, run our main function. Let's wait a second. And we can see that the request was not successful. We got false, 404, not found. Let me navigate to the user API and change user to users, make it plural. Now let's rerun this one. Wonderful, we can see that now the request was successful. We got 200 OK status code. Following, let's see how easily we can obtain the response body. So let's navigate to the user service, and along with these values, let's read the response body. Val body equals users response dot body. Again, let's print out this one. Body, Shift plus F10 to rerun. And we can see that we successfully deserialized the JSON payload into the user instance, setting the appropriate values to our object. The important thing to mention here is that the body method may return null, so we need to keep in mind to handle that appropriately in our code base. When we got right here, we can see that the response, generic response, may be nullable. Wonderful, and life would be much easier if there were no errors. However, they happen and it's better to get more information about them. What we can do right here? Well, let's do it in conditional logic. So let me delete this one and let's handle both cases, the successful and not so successful response. If successful, then I would like to print out the successful. So print on successful response. Let's use string interpolation. Let's use user's response and body. Let me close this one. Otherwise, I would like to obtain the information about the error body, and there is the function called error body that we can use to do that. Val error body equals users response dot error body. The main difference between the body and the error body is that this one returns the instance of user. However, error body returns the response body that again can be nullable and that we need to manually deserialize to the error instance. So let's do that. Let's introduce a new error body data class so that we'll use to deserialize the JSON. Kotlin/file data class error response. I would like this data class to have one field, message, add JSON property that we already saw, message, val, message of string type. Wonderful. Let's get back to user service. And when working with Jackson library, we need to instantiate the object mapper and read this value to obtain the body of the error response. So I'll introduce object mapper, private val object mapper equals object mapper from Jackson alt plus enter import. And here, whenever the error body is not null, I would like to deserialize that to error response instance. So val error response equals error body dot let mapper read value, and first we need to specify it dot string value and the class that we would like to deserialize to. So it will be error response class dot java. Again, problem with plural, this will be a read value. Lastly, I would like to print out this. So print error response, again string interpolation, and this time let's print out the error response. Ctrl Alt plus L. Let's get back quickly to mockon, and instead of returning 200 OK, I would like to return the error response. So let me duplicate that. Let's turn off this one, and for this one, let's specify internal server error with some message. Oops. Wonderful. Right here we need to restart the server because we've added a new path and get back to our main function. Let me go to main, Shift plus F10, or click simply on this. And we can see that the request was not successful. The status code and message was read successfully. And lastly, we were able to deserialize the error response. And this might be useful whenever you would like to access whatever we got there in the payload from the external API, maybe for logging or something like that. Lastly, let's take a look at the response headers because sometimes they can contain really useful information. Let's get back to user service. And in order to read all headers, we can use the headers function. Val headers equals users response.headers. And in order to read a particular header, we will use that just like we would use a standard array. So val custom header value equals headers, and let's specify the name of the custom header, custom header. Let me print out this, print custom header, and let's inject custom header value, Ctrl+Alt+L. Let's get back to Mokun and let's specify this header. So let me copy the name of the header, open up Mokun, let's toggle this one off and open this. Let's restart once again, go to headers, add header, we need to inject our name and specify some value. This time, because we've edited existing root, we don't need to do anything. Let's get back to IntelliJ and rerun our code. Wonderful, we can see that the some value was read successfully. Excellent, let's get back to user API, and so far we've learned how to handle various things related to responses, but get is not the only option we have. Basically, Retrofit comes with 8 built-in annotations: HTTP, get, post, put, patch, delete options, and head. And although the choice will depend on the endpoint we query, I would like to take a closer look at the head and HTTP annotations. So let's start with the head annotation. Let's add a new function, fun head users, call void, and let's mark that with head annotation. In HTTP, the head is used to check if a given resource exists or if it was updated without downloading it. In other words, it's kind of a get in which you should care only about the headers. And the important thing in Retrofit is that functions annotated with head must return void. Otherwise, we'll get illegal argument exception with head method must use void as response type message. Let's take a look at that. So again, I'll use users and go to user service. Let's add a new function, fun head users, and let's use this function. So user API dot head users, and let's switch that in main head users. Let me rerun the code. Wonderful, we don't see nothing because the logic contains nothing, but it proves that this works perfectly. Now let's take a look at what happens when I specify other thing than void. User, Ctrl+S, Shift+F10, and we can see the exception. Head method must be void or unit as a response type. Excellent, so let's make it void once again. As the next thing, let's take a look at the HTTP annotation. So this annotation is pretty interesting as well because it lets us to use a custom HTTP verb for a request. So let's take a look at the example. Let's change the get users to HTTP. At HTTP method equals get, and the path will be users. Path users. Let's get back to main. Let's use the users, successful users response, Shift+F10. Wonderful, so we can see that this one works pretty much the same as the get annotation. So given that we have an existing get annotation, why should we even care about the HTTP? Well, let's see the next example. Let's add a function called delete user. Fun delete users and call list user, for example. And now let's annotate that with delete annotation, of course, users. And additionally, I would like to add a request body. Later we'll see how to add payload to our request, but for now, let's take a look at this example. Body some, for example, user. Control Alt L. Let's go to user service. Fun, delete users. Maybe it doesn't have too much sense from the API standpoint, but I wanted to show you why the HTTP is useful. User API, delete users. I would like to specify some user, one, some, one. Again, let's go to the main, delete users, Shift plus F10 to rerun the code. And again, we can see that we got the error. Illegal argument exception. Non-body HTTP method cannot contain body. So when I get back to user API, let's make one adjustment. Instead, let's use HTTP. For the method, I would like this to be delete. Path will be users. And we can specify one more thing, has body, and set this flag as true. If I rerun the code right now, wonderful, we can see that everything works perfectly. Excellent, let me close this one and let's learn one more interesting thing, URL manipulation. Until now we saw how to use hard-coded URLs and sometimes it will be sufficient. However, in real-life scenarios we need an additional query parameters, path variables sooner or later. So as the first thing, let me show you how Retrofit resolves URLs. Let me get back to the get, and specify users. So we already saw that this one will be translated to HTTP localhost 8090/v1/users. Why? Because in our Retrofit client, we set the base URL as the localhost 8090v1, and this one we'll simply add the path segment to the end of the base URL. Ctrl plus D to duplicate. When I specify the /users, this one will be converted to localhost 8090/users. And lastly, sometimes we may want to change the base URL, for example, to create some subdomain. In such a case, I can simply copy this value, specify it right here, let's say 8080/whatever, and the base URL set in our Retrofit client will be completely omitted and this URL will be queried instead. Sometimes this might be useful, as I told, for example, to query some subdomain for one request. But if you start seeing this more and more in your code base, then it may be worth to think about whether we should add a new Retrofit client, and specify the another base URL for that client. So let me maybe comment these two values so that we have get users only. And following, let's see how to query this endpoint using the dynamic URL. So fun. Let's call it dynamic get users. Dynamic get users. It should return exactly the same. Call list user. And I would like this to take the URL as a string value. And we'll annotate that with URL annotation. Let's import the class. And now let's try to use that. Let's get back to user service. And instead of get users, let's use the dynamic get users. Again, I can simply specify users, and this will be translated to /v1/users. Let's hit main. Oh, I need to switch that in the main function. Let me get back here. Successful users response, Shift plus F10. What you can see right here, HTTP method annotation is required. So I forgot to add that to user API. Let's get back here and let's add get. Again, Shift plus F10. And this time we can see that this is working perfectly fine. When can this be useful? Well, for example, if you heard the application where you need to call different subdomains depending on the user or maybe some other config, then this may be really useful for you instead of introducing multiple things and some ethology. At this point, we know how to work with URLs, so maybe let's see how we can use path variable, for example, to query user by ID. So let me go to the user API and let's add a new get user by ID. So from get user by ID, I would like this one to return the user instance, get users /123. Ctrl+S. Let's go to user service, close this one, and maybe let's get a user by ID. Let me copy simply this method. I would like to leave this successful. Right here will be reading thingies. Let's get rid of this one and get user by ID. Get user by ID. And right now, let's read the body. Val body equals user's response. Body println user. Inject the body. Let's go to the main function. Get user by ID. Wonderful. And the last thing I would need to do will be to simply go to Mokun and add this new endpoint. So let me copy this one, duplicate 1, 2, 3. And whenever you hit this endpoint, I would like to return this user. Let me rerun. Let's check out our config once again. Get user by ID. We are getting user. If the response is successful, we are reading the body. Let me go to here, users /123. Wonderful. Let's hit main. And we can see that the body was deserialized successfully. So we learned how to access the user by ID, but most of the time this will not be useful. And what we would like to do now will be to use the path annotation. So first of all, I would like to specify the user ID here. So user ID will be a long type, path, and let's specify user ID. Lastly, I would like to put a placeholder right here so that Retrofit will know how to bind this user identifier in our URL. User ID. This time, we need to invoke that, specifying the identifier. So I'll go with 1, 2, 3. Main KT, let's rerun. And wonderful, we can see that this is working perfectly. When I go with another identifier, nothing will be printed here because the user response is not successful. We got 404 not found from the API. Similarly, sometimes we need to add query parameters, for example, to sort or things like that. Well, let's take a look how we can do that. Let's go to user API and let's copy this. Ctrl+C. Let's put that get users with sort. Wonderful. And for example, sort by name. Again, this is hard-coded value, so I highly discourage you from doing so. Even if you will be using some defaults, I would suggest you to use the default value in Kotlin arguments. So instead, we can delete that completely. Use the query annotation, sort by string value, and let's specify the name. And this time, when we use that, the sort by query param will be added to every request with the name, and we also have the possibility to customize that. Let's see that in action. Let's go to user service, and successful user response will use get users with sort. Now let's don't specify anything. Let's go to main, successful users response. Let's run. everything is working perfectly. How we can verify what was sent to the server? Well, let's go to Mokun, open up logs, and we can see that the last request right here have the query params sort by name. So we can see that the default value was sent successfully. What happens if I change that? Well, let's go to the user service, another Shift plus F10, and this time we can see that the query parameter was changed successfully. And sometimes this is good because we need to specify, I don't know, 1, maybe 2 parameters. But if you would like to do that dynamic, well, let's take a look how to do that. Let's go to the user API and copy this one, Ctrl plus C, Ctrl plus V, get users with dynamic query params. Instead of query parameter and specifying the value, we'll need to use query map. Add query map parameters map of string and string, Ctrl Alt L. We can put that as an empty map by default. And now let's go to user service, get users with dynamic parameters, and let's specify some params. Well, params map of param 1, 2 value, param 2 to another value. Excellent. Let's invoke that method. Params, Ctrl Alt L, Shift plus F10. Looks like working. Let's go to Mokun. Let's take a look. And again, we can see that both params were added successfully to our request. So again, this may be really useful whenever you need to make that more configurable in your codebase or changes a lot. Great, so at this point, let's learn more about request headers. Headers are inseparable part of every REST communication, and oftentimes we'll have to send additional information like content type or authorization. So this time, we'll learn a few possibilities Retrofit gives us to work with them. Let's start with a single header. For example, we need to add this header for every request. So I will be using the same endpoint, get users with dynamic query params, and let's add a header. How we can do that? We can use the headers annotation, headers, and specify the header. For example, let's specify the user agent, and this will be Codercy application. When I rerun the request and navigate to Mokun, I should see that the user agent header was sent successfully. Of course, I can use this same annotation to append multiple headers. So instead of that, let's use array and specify the first value. Need to use value equals user agent, Ctrl plus D to duplicate, and another header with another value. Shift plus F10 to rerun the request. Let's go to Mokun, let's see, and we can see that both headers, another header with another value and user agent Codercy application was successfully sent. And similarly, just like we did with query params, we can go with dynamic headers. Firstly, let's start with a single header. So this time I will introduce a new function, get users get users with authorization, for example, because this might be useful oftentimes. For example, you will be sending bearer tokens whenever communicating with secured API. Header, this is the annotation, authorization token string value, and I would like again this one to return call list user, Ctrl Alt L. Let's go to the user service. Let me delete this and simply get users with authorization some token value. So we can see that right now we would be able to, I don't know, query our database to get the API key or to generate a new token. Shift plus F10 works fine. Let's go to Mokun, figure out what was happening here. Authorization header, some token value, wonderful. Again, when I go to the API, we can do exactly the same as we did with query map. So we can use header map. And instead of that, headers map string. And this time we can see that just like we did with query parameters, we can pass a map of header names with header values. I will not be showing that. We can go to the next step in our tutorial. Request bodies. At this point we can finally learn how to attach a payload to retrofit request. We saw that with body annotation previously, and let's add a new endpoint. This will be a post endpoint. Post users and fun create user body user of type user. Let me go to user service and let's add a new method. Fun create user, and I would like to instantiate a new user. User ID will be 111, name will be another name, and age will be 30 years. User API dot create user. We need to go to Mokun and prepare for the endpoint. Go right here, go to roots, duplicate this one, and it should handle post. And we don't need to return anything. For example, we can return 201 created whenever this is successful. Let's restart the server, get back right here, val response. Let's add execute. I don't see anything here. Well, I know why. Call. And I would like to return nothing here. Create user. Now this works fine. Let's print out the status code. Println response status code. Ctrl Alt L. Let's navigate to main and invoke our create user function. Create user function. Shift plus F10. 201 created, which proves that everything works fine with that. We can go to Mokun, logs, and let's take a look at body. We can see that it was successfully serialized into the JSON, which proves that everything works fine too from this perspective. Again, let's get back to Retrofit client, and we can see that we've used this factory to serialize and deserialize our payload. So whenever you would like to somehow configure that, this is the place where you should do that. On the other hand, if you would like to send data in a URL encoded form, this is, for example, for the login page or something like that, well, we can use the form URL encoded along with fields. So let's go to user API, fun, create user form URL encoded. It will be returning call or void again, and post users. And as I mentioned, we need to annotate the function with form URL encoded, form URL encoded annotation, and for every field we simply go with field. Again, we can use a field map too, just like we did with URLs or query params. Field 1, and some field 1 value, for example, a string value. Lastly, to send the data as an HTTP multi-part request, we can use the multi-part with part. So copy this one, Ctrl+D to duplicate things in IntelliJ, create user, multi-part. Maybe this does not make too much sense, but I would like to show you how to work with that only. You need to annotate the function with multi-part, and right here we need to simply use part annotation, part name, part, and for example, request body. Excellent. At this point, you know pretty much a lot about how to send different requests to external API and read responses. So, as the last thing, I would like to show you how to add OkHttp client interceptor. If you're wondering why would we need it, then the answer is pretty simple. Oftentimes when working with external APIs, we want to perform some repeatable actions. For example, add some authorization key to every request because we are working with a secured API. I would like to add sometimes some logging or error handling, print out something, send the data, measure something, whatever. And to avoid repeating the code across the whole app, doing that in user service, just like we did until now, we can simply add an interceptor which will affect our calls. So with that being said, let's implement a simple request interceptor. Click right mouse button right here, Kotlin/file, object, and let's call it logging interceptor. Logging interceptor. This one must implement the interceptor interface from OkHttp. So interceptor, Ctrl+E to IntelliJ to speed up the work and implement members. Let's hit OK, and we can see that we need to override the intercept method that returns the response. So as the first thing, let's remove the to-do, val request, chain, request, and this way we'll intercept the outgoing request. Println outgoing request to, and let's read request.url. I would like to read the URL to which we are calling. Nextly, I would like to obtain the response. So val response, chain, proceed, and go with the request. This returns the response, and for example, I would like to return the status code. Println response status code, response.code. Lastly, we need to return the response, so simply return response. Or in Kotlin, I can show you a pro tip. Instead of that, we can go right here, return, and use the also. And within the also, we'll reference to it. So this will have the exact same result, and this is a synthetic sugar in this case. So to summarize, we can see that our logic will print out the information about outgoing requests and the status code of the response of external API. So with that done, we need to modify the Retrofit client to make use of our interceptor. So let's go to our client and let's introduce OkHttp client. Private val equals OkHttp client.builder, add interceptor, and right here I'll refer to our logging interceptor. Logging interceptor dot build. Well, we need to specify the name of our property. OkHttp client, and the last thing right here, we'll use this client. OkHttp client. Ctrl+Alt+L, and let's add a new plain method to user service. So I'll go here, phone get users, user API, get users. Let's take a look at the interface to see whether, yeah, this is a plain method. We are simply expecting the call, get users, execute. Let's go to main, get users, Shift plus F10. And we can see that our interceptor is working perfectly. Outgoing request, response status code. Wonderful. As the last step, let's take a look at how we can add a generated token to every call to the external API. So let's add a new interceptor to make our lives easier. Let's copy logging interceptor, Ctrl+C, Ctrl+V, authorization interceptor. Wonderful. And right here, let me delete this logic for now. What I would like to simply to do here will be to add a new token to every request. So again, we need to obtain the request. So val request with header. This will be a changed request. Chain request, new builder, header. And for the authorization, I would like to specify some UUID random value. UUID.random value and toString. Excellent. .build. And lastly, return chain.proceed and request with header. We must go to the Retrofit client to similarly add that to OkHttp client. So again, add interceptor. And as the interceptor, let's add authorization interceptor. When I rerun the code right now, we should expect that the request contained authorization, some token. So let me open up Mokun. Let's go here. And we can see that authorization header was sent with the random UUID value. So let me open up authorization interceptor once again. And we can see that interceptor is a great way not only to read the data from outgoing requests or incoming responses, but also we can use that to modify our request. Just like right here with header, I highly encourage you to check out what other possibilities are right here. Again, authorization interceptor might be great to, append the generated key to access the database or whatever, so that we don't need to do that in every place in our code base. So whatever can be centralized and to avoid duplication. And that's all for this video on Retrofit 2 with Kotlin. And if you'd like to see the continuation with Kotlin coroutines, then let me know in the comment section below. Thank you for watching and see you in the next one.